Hello, and welcome. We design systems with the best intentions, architecting for resilience and scalability. But in the complex, interconnected world of modern software, major incidents are not a matter of if, but when. When the alerts fire at 3 a.m. and key services start to degrade, who steps in to navigate the storm? That is the world of the site reliability engineer. Today, we're not just going to talk theory, we're going to walk through a case study of a major incident at a fictional e-commerce platform called ChronoCart. We'll follow the SRE team from the first cryptic alert to the final blameless postmortem. Our goal is to move beyond the playbooks and understand the mindset, the coordination, and the technical decisions that turn a potential catastrophe into a resolved incident and a powerful learning opportunity. This is about the human element of engineering under pressure. Our incident begins. At 14:32 UTC, a high-severity alert fires. P99 latency on payment authorization service greater than 2000 ms. Simultaneously, a cascade of secondary alerts begins. Database CPU is high, checkout queue length is growing, and customer support tickets are spiking. The first job of the on-call SRE is not to fix, but to orient. Is this a real fire or just smoke? The SRE's initial actions are critical. They acknowledge the primary alert, establishing themselves as the incident commander. Then, they immediately go to the primary dashboard for the ChronoCart payment service. They aren't looking at logs yet. They are looking at the big picture metrics. Error rates, traffic volume, saturation, and latency, the four golden signals. The latency is indeed climbing, but traffic is stable. Error rates are starting to tick up. This confirms the signal. It's not a monitoring glitch or a benign traffic spike. The fire is real. The SRE declares a Severity 1 incident in the company's incident response channel, automatically paging the core service owners and leadership. The clock is now officially ticking. With the incident declared, the virtual war room is convened. This isn't chaos, it's a structured, coordinated effort. The initial SRE who triaged the alert is the Incident Commander, or IC. Their job is not to type commands into a terminal. Their job is to direct the response. They delegate two key roles immediately, a communications lead to handle stakeholder updates, and an operations lead to execute diagnostic and mitigation steps. The team's first task is to form a hypothesis. The IC asks, what could cause this latency? Team members begin investigating in parallel. One engineer checks recent deployments. Another examines the database for long-running queries. A third checks the logs of the payment service itself. All findings are reported back into the central incident channel. This is crucial. It prevents duplicate work and builds a shared mental model of the problem. A key finding emerges. Logs show timeout errors when calling the primary third-party payment processor. Hypothesis: the external processor is slow or unavailable. Next step: can we prove it? The operations lead runs a command to test connectivity directly to the processor's API endpoint, bypassing their own service. The connection hangs. The hypothesis is confirmed. The priority in a major incident is always to restore service. Finding the exact root cause can wait. Now that the team has a high degree of confidence that the external payment processor is the issue, the question shifts from why to what can we do right now? This is where system design pays off. The architects of ChronoCart had built-in redundancy. The platform was integrated with a secondary backup payment processor. The SRE team's path to mitigation is now clear. The incident commander makes the call. Let's initiate a failover to the secondary processor. This is a well-rehearsed procedure. The operations lead uses a feature flag, controlled through a central configuration service, to reroute all new payment authorizations to the secondary provider. They don't need to deploy new code or restart servers. It's a configuration change that propagates within seconds. The team watches the dashboards intently. The P99 latency for the payment service drops dramatically, back into the double-digit millisecond range. The error rate plummets to 0. The checkout queue begins to drain. The fire is contained. Service is restored. Only now, with the customer impact resolved, does the investigation into the primary processor's failure begin in earnest. The incident is resolved, but the work is not over. This is arguably the most important phase, the blameless postmortem. The goal here is not to find who made a mistake, but to understand the systemic factors that allowed the incident to happen and to identify opportunities for improvement. The SRE team leads this meeting, bringing together everyone involved. They review the timeline of events, the actions taken, and the impact. Key questions are asked. Why was our monitoring slow to detect the external provider's latency? Could our system have failed over automatically? Does our runbook for this scenario need updating? The outcome is a set of concrete, actionable follow-up tasks, each assigned an owner and a deadline. For instance, an engineer is tasked with implementing proactive health checks against the payment gateways. Another is assigned to automate the failover process. This is the core loop of SRE. By learning from failure, we build a more resilient, reliable, and intelligent system for the future.